Hello, my name is Ketil Malde. I'm a researcher with the Institute of Marine Research and the University of Bergen, Norway. I'm going to talk about the role of machine learning in the future of marine science. The roots of marine science is in resource management. What happens to our fish stocks in the future if we catch a certain amount this year? But today we would like to answer more ambitious questions like how will global warming affect the productivity of our oceans? What will a reduction in ice coverage mean for our Arctic stocks? How will migration and invasive species affect the local biodiversity? And what are the effects of overfishing or of microplastics? These are difficult and complex questions, but what if we could just Google the answers? Search engines used to be very simple text-based tools. It was considered a great step forward when you could paste in an image and have a search engine show you similar images from the internet. In 2014, the search engine leaves a little to be desired. We have search using a picture of a cat in a window, and although one of the images in the results is indeed a cat in a window, the images in general are only superficially similar with some of the same colors and rough shapes, but they depict entirely different things. Today, we get much better results. The cat breed is now identified as a British Shorthair, and the relevant links are provided. A number of pictures of cats are found. All are gray British Shorthairs on light backgrounds like our search image. If I hired a human assistant and asked him to read through all 6 billion web pages to find relevant pictures and information, he could hardly have done a better job. And this is only 6 years later. So what has happened over these 6 years? Two things: machine learning algorithms and the internet. The internet has given the search engines access to millions and millions of cat pictures, along with their associated data. Machine learning is the magic that turns vast troves of data into information and automation. Today, the internet is coming to marine science in full force. Previously, data collection was expensive and complex. If you wanted to do an acoustic survey, for instance, you needed a ship outfitted with the appropriate equipment and a crew. Today, you can pick up your phone and a commercial company will quote you a price for a drone operation doing the same thing. This is just one example. Rapid technological advances have decreased costs of sensors and deployment, and we now see the beginnings of mass surveillance of the ocean. Currently, marine scientists are struggling to deal with the torrent of incoming data. This presents both an opportunity and a challenge. Maybe you remember going from film to a digital camera. Full of enthusiasm, I took tens or hundreds of pictures in a single day. And then did I spend the next week tagging and categorizing all these pictures? After a couple of brief attempts, I gave up and my images are mostly still uncategorized. And just as well, today, of course, I can just ask my computer. So when can we apply this kind of computer intelligence to marine scientific data? It's not as easy as it might look and much harder than categorizing images for three reasons. One is that marine data is vast and heterogeneous. We must automatically catalog, process, interpret, and aggregate data of a variety of types and from a large number of different sources. Image analysis has seen an incredible effort over the last years, and we can build on top of this, but there's a lot that needs to be built. Second, the question we want to ask are much more complex. An image is a static piece of information to analyze, but an ecosystem consists of a complex web of species and processes that continuously interact and respond and adapt to each other. This makes the ecosystem a complex adaptive system, and these are very hard to model accurately. And finally, the true answer to many of our questions are often unknown. We can't just ask a human expert whether our predictions are correct. Today, we know how to make machine learning systems that mimic our reasoning when there is a known truth or expert opinion to emulate. When no such ground truth or expert is available, we need to develop advanced, unsupervised methods that can discover patterns from the data directly. And in order to trust such a system, we need to make them interpretable, providing us not only with an answer, but also an explanation of their reasoning. But a few years ago, image search seemed like magic too. Images may be much easier to analyze than ecosystems, but our progress reveals a glimpse of what is possible.